Kuzampula. Welcome to Bhutan e-learning program. I'm Vishal Biswa and I'm currently working in Mothang High Secondary School. Today I'm going to present on the topic applications of determinant. Now this topic is intended for classes 11 and 12. Before I move on with the topic, let me highlight with the objectives of this lesson. At the end of this lesson, you should be able to find the area of triangle using determinant, give the condition for 3 points to be collinear, find the area of quadrilateral, prove determinant using properties of determinant, solve system of linear equations using Cramer's rule. Now let me begin with the topic. First of all, let's see how to find the area of triangles. Now in your lower classes, you studied a different formula, various formula to find the area of triangle. Let me give you one example that you learned. For example, if I ask you to find the area of this triangle, now if you know the base of this triangle, if you know the height of this triangle, I have triangle A, B, C. Now if I ask you to find the area of this triangle, I'm sure you will be in position to give me the formula. The area of triangle will be area of triangle ABC will be equal to half times base times height. I know most of the students are familiar with this formula and you can give the answer very easily. Now instead of using this formula, if I change the question a little bit, now instead of giving base and height, I give you 3 vertices of this triangle and I'm asking you to find the area of this triangle. Now when the 3 vertices are given, and if you are asked to find the area of this triangle, then what you have to do, you have to use determinant method to find the area of this triangle. How to find the area of triangle using determinant? Now area of this triangle, area of triangle will be, area of triangle ABC will be equal to, you have to take the modulus of half and you have to take the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1, close the determinant. You are taking modulus because area of any shape will never be negative. Area of any shape will always be positive or 0. It cannot be negative. Therefore, even if you expand this determinant, if you get negative, you have to take it positive. That's the reason why we take modulus. Let's try one example. For example, in this question, I'm asking you to find the area of triangle whose vertices are, 3 vertices are given, you have to find the area of this triangle. Now let's find the area of this triangle using determinant method. In this question is asking us to find the area of this triangle with the vertex having these coordinates. Now to find the area of this triangle, you can name the vertex. Let it be A, let it be B, let it be C. You can mark this one, x1, y1, x2, y2, x3, y3, this is 2. I just marked this vertices. Now you find the area of this triangle using determinant method. Okay? So area of this triangle, area will be equal to of triangle ABC is equal to, you have the formula, half modulus of half x1, y1, 1, x2, y2, 1, x3, y3, 1, close the modulus, will be equal to. Now substitute the value of x1, y1, x2, y2, x3, y3 in this formula. So you are going to have x1 is -2, -3, 1, 3, 2, 1 and I have -1, -8, 1. Now you can find the value of this one by expanding this determinant from first row. You can expand the determinant using first row like I taught in previous lesson. So I'm going to have modulus of half. Let me expand this. I'm going to take -2, I'll take the minor of this one, so it will be 2 plus 8, 2 plus 8. Now second term, negative of -3 will be positive 3, take the minor of this element will be 3 times 1, -1 times 1 will be 3 plus 1. Now take the third element plus 1, take the minor of this element, when I take the minor of this element, 3 times negative it will be -24 plus 2, negative 24 plus 2. Okay, close the bracket. Okay, I'm taking the modulus. So I'm going to have half. So this will going to give you negative 20 plus 12 plus minus 22. Okay. So half negative 30. Now divide, it will be negative 15. But I got the value of negative 15. Here you have modulus. The reason for modulus is you have to ignore this negative because the area of triangle cannot be negative. Therefore, your final answer will be 15 square unit because the area is given always in square unit. So this is how you find the area of triangle using determinant method. I hope you understood. Let me give you condition for collinear, 3 points to be collinear. I have given you 3 points A, B, C. Now tell me, is this 3 points collinear? No, these 3 points are not collinear because these 3 points are not on one straight line. Okay. Now can you draw a triangle using these 3 points? Yes, you can draw a triangle using these 3 points. You have, okay, you have the triangle, this triangle. I made a triangle after. Can you find the area of this triangle? Yes, you can find the area of this triangle. Now tell me, what will be the area of this triangle? Will it be negative or 0 or positive? The area of triangle will be positive. It will going to have some value, isn't it? Now, what you do, you try to press this point B. Now I press this point B. I shift the position of point B to this point. I'm applying some force and trying to push point B. Now point B is here. Now draw. Now this is the final position of point B after applying some force. Now you draw a triangle using this point, these 3 points. You're going to have triangle. Now compare these two triangles. This triangle is smaller than the previous triangle. So what happened to the area? Area of triangle decreased. Am I right? Now press some more, apply some more force and push it down to this point. Now B is on this point. Now tell me, what happened to the area of triangle when you pushed this point B down to this point? The area of triangle became 0 because you cannot form area triangle using these 3 points because they are on same line. Therefore, the condition for collinearity is the points A, B, C are said to be collinear if the area of triangle formed by these points is 0. That is, when you apply the formula area of triangle, this should be equal to 0. This is how we check the collinearity of 3 points. I hope you understood. Now let's try one question on this topic. My question says, using determinant, prove the following points are collinear. I have 3 points. You just need to prove that these 3 points are collinear. To prove these 3 points are collinear, what you need to find? You need to find the area of triangle. If you get area of triangle is equal to 0, that means these 3 points are collinear. If it's not equal to 0, these 3 points are not collinear. That's what you have to do. Okay, let's do together. Now, find the area of triangle using these points. So area will be equal to, you have the formula, half modulus of half x1 y1 1, x2 y2 1, x3 y3 1, close the modulus. So substituting value of x1 y1 x2 y2 x3 y3 from this given points, you're going to get half times, you have 11 7 1 5 5 1 negative 1 3 1. Okay. Now you expand this determinant using expanding from first row. When you expand this determinant from first row, you're going to get half. So when you expand, you're going to have first element, and minor of first element will be 5 minus 3. 5 minus 3. Second minus second element minor of second element will be 5 plus 1, because minus of minus 1 will be plus 1. 5 plus 1 plus third element. Now you take the minor of third element, you are going to have 15 plus 5 plus 5. Okay, you have this. Now close the determinant. Okay, you have half. Let me simplify this. 22, 5 minus 3 is 2, 2 times 11 will be 22. 5 plus 1 is 6, 6 times 7 will be negative 42. Okay, 5 plus 1 will be 20 plus 20. Okay, I have this. Now let me try to simplify this. Half 22 plus 20 is 42, minus 42 is 0, times 0, answer is equal to 0. Now you got it. The area of this triangle is equal to 0. What does it mean? It means that these 3 points, these 3 given points are collinear, because area of triangle is equal to 0. I hope you understood. Well, let me come to the concept, how to find the area of quadrilateral. Do you know what's quadrilateral? Quadrilateral is any geometrical shape having 4 vertices and 4 sides. Now, I am going to teach you how to find the area of quadrilateral using determinant. Let me teach you how to find the area of quadrilateral using this example. Now, if you check this out properly, this quadrilateral can be divided into 2 triangles by drawing one diagonal. Let me draw one diagonal. Okay, I made one diagonal here. Now, I divided the quadrilateral into 2 triangles. First triangle, second triangle. Now, to find the area of this quadrilateral, you can find the area of first triangle and you can find the area of second triangle and add the area of 2 triangles. That will going to give you the area of quadrilateral. Yes? Okay. So, area of this quadrilateral, area will be equal to area of first triangle plus area of second triangle. Am I right? This plus this will going to give you the area of the whole quadrilateral. First you find the area of first triangle. So, in first triangle you are going to have half x1 y1 1, x2 y2 1, x4 y4 1. Because I took the first triangle, I have x1 y1 x2 y2 x4 y4 first triangle, plus now you take the area of second triangle. So, I have x2 y2 x3 y3 x4 y4. Therefore, area will be equal to modulus of half. The determinant will be x2 y2 1, x3 y3 1, x4 y4 1. When you add this 2 area of triangle, you are going to get the area of quadrilateral. That is how you use determinant method to find the area of quadrilateral. Now, let us see one example to find the area of quadrilateral. I have the question, and question says that find the area of quadrilateral whose vertices are, I have A, B, C, D. This is a quadrilateral because there are 4 vertices. Now, let me find the area of quadrilateral having these vertices. First of all, you can name the vertices. I have A, B, C. This can be x1, y1, x2, y2, x3, y3, x4, y4. Now, to find the area of this quadrilateral, first of all, you have to divide the quadrilateral into 2 triangles. Then add the area of this 2 triangles. That will going to give you the area of quadrilateral. Now, okay, area of quadrilateral ABC, area of the quadrilateral ABC will be equal to half times you have x1 y1 1, x2 y2 1, x3 x4 y4 1 plus half times modulus of half times you are going to get x2 y2 1, x3 y3 1, x4 y4 1. I taught you the formula just before this topic. Now, substitute the value of x1 y1, x2 y2, x3 y3, x4 y4 in this formula, then you are going to get the answer. Expand this determinant, that will going to give you the area of quadrilateral. Let me help you to do this. First case, first element, minor of this element will be 1 plus 2, 1 plus 2, minus of minus 1 will be plus 1, minor of this element 1, 3 plus 1. Take the third element, minor of this element will be negative 6 plus 1 plus half times first element, minor of first element 3 plus 2 minus second element minus 2 plus 1, third element minus third element 4 plus 3. Okay. If I simplify this, I am going to get half, I am having 3 plus 4 minus 5 plus half, I am going to get 5, 15 plus 1 plus 7. If I simplify this, I am going to get half times 2 plus half times 21. Now, if you simplify this one, you are going to get this expression. Now, when I simplify this, you are going to get 2 cancel, 1 here, modulus of 1 is 1, plus if you cancel this, you are going to get 10.5. Now, when you add this one, my final value will be 11.5 square unit. So, this is the area of this quadrilateral. That is how you apply determinant method to find the area of the quadrilateral. I hope you understood. Now, let me go on with properties of determinant. This properties of determinants are very important to prove some determinant questions using the property. Let me explain the properties of determinant. First property I have, property number 1, if each entry in any row or each entry in any column of a determinant is 0, then the determinant is equal to 0. Let me take one example. I have 1, 2, 3, 1, 1, 1, 0, 0, 0. Now, you can give the value of this determinant without expanding this determinant. This determinant will be directly equal to 0. The reason is because in this case the third column, the entries in the third column all are 0. That is exactly what the property explains. Property number 2, if rows be exchanged into columns and columns into rows, the determinant remains unaltered. For example, I have the determinant, first determinant 1, 2, 1, 0, 1, 1, 2, 1, 1. Now, let me find another determinant. I am going to obtain this determinant by interchanging rows into column and columns into rows. So, I am going to get 1, 0, 2. I made this row to column. So, 2, 1, 1. I made second row to second column. Last one I have 1, 1, 1. Now, according to this property, it says that if you evaluate the value of this one and evaluate the value of this one, these two are going to have equal value. That is, determinant 1 will be equal to determinant 2. This is what property 2 explains. Property 3, if any rows or columns of a determinant are interchanged, the resulting determinant is negative of original determinant. Now, here let me give you first determinant 1. I have 1, 2, 1, 1, 1, 1, 3, 4, 5. Now, let me form another determinant by interchanging first column and second column. Now, in this case, I am going to write second column as first column and first column as second column. Now, what I did, I interchanged two columns. When I do this, I am going to get 1, 1, 1, 1, 2, 1. Third column will be same, 3, 4, 5. Now, if you find the value of this determinant and value of this determinant, the value of this determinant will be equal to negative of value of first determinant. That is, determinant 2 will be equal to negative of determinant 1. This is what property 3 explains. Property 4 says, if any two rows or column in a determinant are identical, the determinant is equal to 0. For example, I have determinant is equal to 1, 2, 1, 3, 1, 3, 2, 5, 2. Now, if you expand this determinant and find the value of this determinant will be equal to 0. You do not need to expand, you can use the property and to find the value of this determinant. This determinant will be equal to 0 because in this case, if you see first row and third row are equal, means entries are identical. That means determinant will be directly equal to 0. So, you do not need to expand, the value will be directly equal to 0. That is exactly what property 4 explains. Property 5, if all the elements of any row or column be multiplied by non-zero real number k, then value of new determinant is k times the value of original determinant. For example, I have determinant is equal to, let us say A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, what I am going to do? I am going to multiply the entries of first row by non-zero real number k. Let me multiply value. So, new determinant will be equal to what I did. I multiplied A1 k, B1 k, C1 k, A2, A3, B2, B3, C2, C3. Value of this determinant will be equal to k times the value of first determinant, because I multiplied each term here, each entry in the first row by non-zero real number k. Therefore, value of this determinant will be k times the value of first determinant. This is exactly what property 5 explains. Property 6, if each entry in a row or a column of a determinant is written as sum of two or more terms, then the determinant can be written as sum of two or more determinants. Here it means that, let me give you one determinant, that is, you have A, B, C, A1, B1, C1, A2, B2, C2, A3 plus M, B3 plus N, C3 plus N. Now, if you check this determinant, the third column is written as sum of two entries. This determinant can be written as, will be equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, this can be added with another determinant. So, it will going to have A1, B1, C1, A2, B2, C2, and third entry, instead of writing A1, A3 plus B, what you can write? You can write the second number, M and P. Let me write it P here, M and P. Okay. So, this is how, if this is exactly what property number 6 explains. Now, these properties can be used to prove some determinant questions. Let me try one question, explain one question by applying property of determinant to prove the determinant. I have one example, that is, prove that the determinant is equal to, you have determinant x, x square, x cube, y, y square, y cube, z, z square, z cube is equal to, you have to prove that it is equal to x y z times x minus y, y minus z, z minus x using properties of determinant. So, to prove this one, first of all you have to take left hand side. When I take left hand side, I have x, x square, x cube, y, y square, y cube, z, z square, z cube. Now, to prove the property using the to prove the determinant using the property, it is always wise to follow some steps. The step is, first of all, you check whether there is 1 1 1 in any row or any column. If there is no 1 1 1, now you check whether you can take anything common from rows, any rows or column. If that is not possible, make any rows or any column common by applying properties. If you follow that method, you can solve determinant question very easily. For example, in this case, if you see there is no 1 1 1 in any row or column, now you have to check in the interest of this determinant to take one and to take common to make any row or any column 1 1 1. So, here if you see from row 1 I can take x common because there is x x x. From row 2 I can take y common, y y y. From row 3 I can take z common because there is z z z. So, when I am taking x y z common from r1 r2 r3, I am going to get x y z. I took it common. Now, I am going to have 1 1 1. So, here will be x y z. Here will be x square y square z square. After reaching this to this point, now you have to try to make this value 0 and this value 0. This is second row and this is third row. You can make second row 0 and third row 0 by applying the rule, that is second row is second row minus first row and third row is given by third row minus first row. When you apply this one, see here, second row 1 minus 1 will be 0, third row 1 minus 1 will be 0. So, this rule is applied to all the entries in second row and third row. When I apply this, I am going to get, I already have x, y, z. Here I am going to have, I did not teach first row. So, 1 x, x square. In this case, I am going to get 1 minus 1 will be 0. Now, y minus x, x. Here it will be y square minus x square. Here 1 minus 1 will be 0. Here z minus x. Here z square minus x square. Now, before you simplify, first of all you check this one, y square minus x square. Applying the formula, that is a square minus b square will be a plus b, a minus b. That is, applying the formula, a square minus b square is equal to a plus b, a minus b. This formula can be applied here in this term, in this term. When you apply this formula here, you are going to get x, y, z, 1, 0, 0. Here it will be x, here will be x square, y minus x. Here you can get y minus x, y plus x. Applying the formula, here it will be z minus x, z minus x, z plus x. When you close this one, you have this. Now, if you check, you can take y minus x common from second row, z minus x common from third row. When I take this common, you are going to get x, y, z, y minus x, z minus x. The remaining terms will be, I have 1, 0, 0. Here it will be x, 1, 1. Here it will be x square, y plus x, z plus x. Now, I have the determinant in simplest form. Now, what you can do is, now you can open this determinant from first column. When you open, you are going to get the answer, y, x, y, z, y plus x, z minus x. So, you are going to get, to open, this will be 0, this will be 0. When I open this one, this 2 will be covered. So, you have z plus x minus y plus x. When I simplify this, I am going to get x y z, y minus x, z minus x. When I open the bracket, I am going to get z plus x minus y minus x. Plus x minus x will get cancelled. So, finally, I am having x y z, y minus x, z minus x, z minus y. Now, let me compare this one with my proof. It says that prove that this is equal to x y z. So, I have x y z and x minus y, y minus z, z minus x. Now, compare my answer with the proof. I have x y z, okay, this is done. I have both here, y minus x, but here it is x minus y. To get x minus y, you have to take minus common. When you take minus common, you are going to get minus x minus y. So, just to interchange the terms, you can take minus common, okay, times. Now, I have z minus x, I have z minus x here, here z minus y, here it is y minus c. Again, to interchange, you can take minus common, y minus c. This minus will get cancelled. Therefore, my answer will be z x minus y. So, z minus x, y minus c. So, here z minus x. This is how I use the property to prove the determinant. Properties can be used to prove the given determinant. I hope you understood. You can solve many questions, but always follow one technique, that is, try to look for 1 1 1. If there is no 1 1, take common. If there is no common, you make common. This will be helping you to prove the determinant questions. Now, let me come to the last method, application. The determinant method can be applied to solve the system of linear equation. Now, this method is called Cramer's rule. This method was named after the mathematician Gabriel Cramer. While solving the system of equation using determinant method, it is important to check the given equations for consistency. The consistent equations, the given set of equations are said to be consistent if they have solution. The given equations are said to be inconsistent if they have no solution. Now, with this, let me explain you one question, that is, solve the following system of equations using Cramer's rule. I have the equation, that is, x plus 3y is equal to 2x minus 6y is equal to 7. Now, before you start solving, first of all, you have to define the value of d, dx and dy. There won't be dz because this is a system equation with two variables. So, d will be equal to, is given by coefficient of x and y. So, 1, 2, 3, negative 6. dx will be equal to, now in place of 1, 2, you will substitute with constant terms. So, you have 2, 7, 3, negative 6. So, dz will be equal, dy will be equal to, it will be equal to, so you are going to have 1, 2, in place of this you are going to substitute with constant term, you have 2, 7. To check the consistency, first of all you have to find the value of d, determinant d. Determinant d will be either 0 or not equal to 0. If d is not equal to 0, then it is said that equation is consistent with unique solution. It means x will going to have one value and y will going to have one value. If there is z, z will going to have one value. But if d is equal to 0, then you cannot conclude it can be consistent or inconsistent. So, to find it, you have to find the value of dx, dy, dz. If there are 3 variables, if there are 2 variables, dx and dy. If one of dx, dy, dz is not equal to 0, that means the equation is inconsistent with no solution. But if dx is equal to dy is equal to dz is equal to 0, if dx, dy, dz all are equal to 0, that means the equation is consistent with infinitely many solutions. So, this is the rule to check for consistency. Now, you check for consistency. So, d will be equal to negative 12, which is not equal to 0. Therefore, this equation has is consistent and has unique solutions. So, now you find the value of dx. dx will be equal to 33. Now you find the value of dy will be equal to, so I have the value, therefore x is given by dx over d, which will be dx is negative 33 over negative 12, negative negative cancel, answer will be 33 over 12. So, x, the value of x will be 33 over 12, y will be dy over d, which will be equal to 3 over negative 12, 3 1 is 3, 3 4, answer will be negative 1 over 4. So, you got a unique solution for x and y. This is the way how we solve system of equation. Before I end my lesson, let me give you assignment for the lesson. I have 3 questions for you. So, try these questions, explore more on determinant with these questions. Let us just revise whatever we learned in this lesson. In this lesson, we learned to find the area of triangle using determinant, give condition for 3 points to be collinear, find the area of quadrilateral, prove determinant using properties of determinant, solve system of linear equations using Cramer's rule. I hope you enjoyed my lesson like I did. Thank you. Tashitale.